Hello everyone, Assalamu alaikum. Welcome to the 7.2 probability involving permutation and combinations. So we will start with permutations first. There are 6 important techniques in permutation, but let's look at the few objectives. The first 3 objectives for the permutations. These are the 3 first objective for the permutation, which is the first one is using the techniques of counting. And then we will find the permutation of n different objects. And then we will find the number of permutation of r objects from n different objects. So this first 3 objective that we will start with. Let's have a look at the example number 1. In a computer game known as Maze of Tunnels, there are 2 tunnels leading from point A to point B. So this is point A to point B. There are 2 tunnels, 1 and 2. So we put there 2 as a total. And then we have 3 tunnels leading from point B to point C. So this is 1, 2, 3. 3 in total. And then there are 4 tunnels leading from point C to point D. So 1, 2, 3, and 4. 4 in total. Calculate the number of routes a rat can take to move from point A to point C via B. So let's have a look how many routes that we can count by using the technique of counting. So the first one is, this is the first route, this is the second route, and this is the third route. So for now we know there are 3 routes, but we can also begin with this part. That's why this is also called one route. And then we have 2 routes, and then we have another route. So in total, we already have 6 routes. So that is the use of the technique of counting. We count each of every journey that the rat will use. So basically, it is just actually 2 times with 3. We will get the 6 to get the total journey from A to C. So we can write here, it is just 2 times 3. It will give us 6. There are 6 ways. How about the number of routes a rat can take to move from point A to point D via point B and C? So let's count this as a beginning. We count this from A to D, where this, and this is the first route. This, and this is the second route. This, and this is the third route. And then this, and this will be the fourth route. So there are so many ways to get to from A to D. So I only teach you the first 4. Try to find all possible journey from point A to point D. Okay? Count it by yourself. For now, I give you the answer. The answer is just 2 times 3, and then times with 4, you will get 24. So it's just very simple. 2 times 3, and then times with the 4. It will give us 24 ways of journey from point A to point D. That is the use of counting. Let's go to the example 2. There are 3 pictures, picture A, B, and C, to be hung in a line along the wall. So let's say this is my picture A, picture B, and picture C. And how many ways can they be arranged? So the word arrange will help you note that this is actually permutation. But we will begin with the first goal, which using the technique of counting. Let me teach you how we can find all possible arrangement. The first arrangement is A, B, C. The second arrangement, I can also arrange A, but C, B now. Now, there are another possible arrangement, which is start B, picture B, and then A, C, or I can start with D, but C, A. Now, I can also start with the arrangement of C, picture C. Then I'll get here A, B, and then, or I could start with C also, but B, A. And so I know by using the technique of counting, there are 6 possible arrangements. So we call this 6 possible ways to arrange the pictures. These are the 3 pictures, isn't it? So we can rearrange it in a row, in a line, they say, and we count it one by one, and we know that there are 6 possible ways to arrange those pictures. And so I put here as a conclusion, there are 6 ways. But if you write it, if you learned it in permutation, the way to write your answer is just 3 factorial. And 3 factorial is actually 3p3. This is what you have learned in the school, where this is how we write them. And this is the first important technique in permutation, which is n different object, and Pn is equals to the n factorial. Remember, this thing is called as n factorial, or nPn. It means every object is taking account in this part. And so we are taking account of every object, every pictures to be lined up in a line. And so every pictures is taking account, and so we put the total numbers of the picture, which is 3p3. We will get 6 ways of arranging them. So this is by using the technique of permutation. Well, this is using the technique of counting one by one, and I sometimes call this manually. And this, I call it auto, by using the knowledge of 7.2 permutation. Let's have a look at another example here. So how many different word codes? Okay, codes means like your password code, like that, okay, can be formed from all the letters from the word logarithm. Let's say these are the only options that we have, the alphabets that we have, okay, and we can arrange them in how many ways that we can use these alphabets. So let's count this one by one. What is the total letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 total letters. Alright, so these 9 total letters can be arranged in so many ways. And so it is NPN. NPN. In this case, number 9, P9, which also we call it as 9 factorial. So if you use your calculator, so 9p9 is equals to 362,880 ways. Wow, there are 300,000 to find all possible ways of arrangement. Do we want to count it manually until 300,000? No, we do not want that. That's why the use of permutation, the technique of permutation is being taught to us because we can use this automatically. Alright, let's go to the example 4. How many ways can 5 people be seated on the 5 chair arranged in a line? So you're going to highlight this word, arrange in a line, if there is no condition imposed. What does it mean by no condition imposed? It means that any person can sit on the first chair. So this is called as the first chair, second chair, third chair, fourth chair, and the fifth chair. So I label it here in the first kotak, first chair, second chair, third chair, and so on. Okay, yang paling first ni, yang paling penting ni. First chair can be seated for whoever person. Tak kisahlah person A, person B, or person C, or person D, or person E. Tak kisah siapa pun yang boleh duduk di kerusi yang pertama. So we call them 5 people can be seated there. So let's say lah people A already seated there. Tinggallah orang apa? Tinggallah orang B, orang C, orang D, orang E. So untuk chair yang kedua, untuk kerusi yang kedua tinggallah 4 orang. So bila kita dudukkan dia seorang, tak kisah siapa-siapa pun, tinggallah 3 orang untuk chair yang ketiga. Pemilihan. Tinggal 3 orang saja yang boleh duduk di situ. So bila lah seorang lagi dah duduk, tinggallah 2, tinggallah 1. And so kita darabkan semua ni, kita akan dapat sebenarnya 5P5. Okay, ataupun ditulis sebagai 5 factorial. So 5 factorial sebenarnya bernilai 120 ways of arrangement. Tak kisahlah siapa pun yang duduk di kerusi yang pertama. Okay, so 5 orang boleh duduk di kerusi yang pertama. Bila seorang dah duduk, tinggal 4 orang saja boleh duduk di kerusi yang kedua. And so on and so forth. Sehingga kita faham bahawa inilah konsep permutations. 5P5 is no conditions, no condition imposed. And so we find every possible arrangement. This is called as all possible arrangement. Okay, fahamkan dulu apa itu all possible arrangement. Sebab dia tak kisah siapa pun yang duduk di tempat yang pertama ini. And so you understand the basic concept already. Yay. So now the second question here, it's very, very unique. Sangat interesting sebab dia kata the first chair is reserved for one particular person. Dia dah reserve untuk salah seorang sahaja yang boleh duduk di kerusi yang pertama. So the first chair here can only one of them. Contohlah saya pilih orangnya orang C. Hanya orang C sahaja boleh duduk sini. Okay. Ataupun kalau saya tak nak orang C pun, hanya orang E sahaja yang boleh duduk sini, asalkan salah seorang sahaja yang boleh duduk di tempat yang pertama, di chair yang pertama. Kerusi yang pertama ni hanya salah seorang sahaja sebab dia yang kata one particular person only. So the way we write the permutation is 1P1. Okay, 1P1 sebenarnya bernilai 1. 1 bermaksud only one person, only one person can be seated on the first chair. Itulah yang dimaksudkan sebagai 1P1. 1P1 bermaksud one particular person. So kalaulah seorang dah duduk situ, tinggal berapa orang duduk di chair yang kedua ni? So tinggallah, contohlah E dah duduk, tinggallah A, B, C dan D. So how many of them can be seated on the second chair? There are 4 of them boleh duduk di kerusi yang kedua. Let's say lah A dah duduk, tinggallah B, C dan D. Tinggallah 3 orang saja. Let's say lah B dah duduk, tinggallah 2 orang saja. Let's say C dah duduk, tinggallah seorang saja D. So you times all of them together, times, there is actually 1P1 darabkan dengan 4 factorial. Kita boleh tulis begitu juga. factorial. So maksudnya ia bernilai 24 cara susunan. See? Cara susunan dah berkurang disebabkan only one person can be seated on the first chair. Kalau you tengok yang pertama ni, no condition imposed, there are 5 people. 5 people can be seated on the first chair. That's why the number of ways is a lot. The number of arrangement is so many. But if there are only one person be seated on the first chair, the number of ways is a bit smaller. Thank you.